We're going to build a beam robot. And in a moment, I'll explain what in the world beam means. And so let's go ahead and I want to share my desktop here. So here's a picture of the kit that we're going to be building. Here it is done, ready to go. Let's take a moment here. Let's talk about beam. Now, you might think of beam as a bolt of light or something like that. We might have a flashlight beam. But today, beam means something special. It stands for biology, electronics, aesthetics, and mechanics. So first of all, biology. The purpose of a beam robot is to imitate life. It's to pretend to act as if it is alive and would respond like a bug would usually, or a plant sometimes. The case with our robot will respond to sunlight. As soon as you expose it to light, then it will start bouncing around. And if you cover its light source, then it will go back to sleep. Now, electronics, of course, with beam robots, they use electronic parts. And by electronic parts, we mean as opposed to doing something with springs and gears, we use electronics to accomplish the behavior that we're after. Aesthetics, that's a fancy word for hey, it should look cool. And I hope you agree that this little beam robot looks pretty cool, bouncing around on his 3 little capacitor legs. And by the way, most beam robots, when they're built, they do not have a circuit board, which is this main part. People are expected to solder or join electronic parts right to the other parts. But that is very difficult to do. I much prefer working with a circuit board, so I designed this circuit board for you so that you can, even if you're just starting in electronic soldering, you'll be able to build the kit today. Last but not least, in our explanation for beam, we have mechanics. Mechanics means that it works without a microprocessor. Now, most robots have some kind of a computer, whether it's an Arduino Uno or other microcontroller, or it's a Raspberry Pi. Usually people are writing computer programs in order to tell the robot what to do. With ours, there is no computer. With a beam robot, using electronic parts, we design it to behave a certain way, and it just does that through the mechanical setup within our electronic parts. Now, you might think of mechanics as weird when it doesn't just mean the motor. Of course, the motor is moving. What it means is we're using an electronic mechanism in order to send the pulses of voltage to our motor so that it will spin around. The next thing I want to share with you is if you do not have a kit yet and you'd like to get one, or if you'd like to have the printable instructions, this is where you can go. It's fvresearch.com. From the main page, what we're looking for is BeamBot soldering kit. That's what we're going to be building today. And once you click on it, then you scroll down a little bit and you have this little guy right here. Click to download. When you click on that, then you'll be given the ability to save the actual printed instructions, which I have right here. Now, the nice thing with these instructions is not only do they give you a list of all the parts, but they give you step-by-step directions on how to build this. But of course, we're going to build it together. We're going to get ready now to build our circuit. And of course, for this, you need a soldering iron and additional tools. And this printable list here goes through the tools that we need. So let's take a moment to talk about everything you need to build the circuit today. First up, these are things here, these bullet points are items that are not in your kit. And first, of course, is eye protection. Anytime you're working with soldering irons, you should always have something covering your eyes. I highly recommend safety glasses, but if you don't have safety glasses, even your regular eyeglasses that you wear would be fine. If nothing else, if you have a pair of sunglasses or your parents have a pair of sunglasses, if nothing else, you could even do that, but I really recommend that you have something protecting your eyes. And that's true for anyone who's sitting next to you or close to you, should also have eye protection on you. A soldering iron, by the way, is going to be heating things up to about 600 to 700 degrees Fahrenheit. And if something is accidentally flicked towards you, then it's going to be very hot. We do not want it to hurt your eyes. We also, of course, need an electronics soldering iron and solder. So the soldering iron I'm using is like this. Sometimes they have an adjustable temperature, sometimes they're a fixed temperature, but you would like to be using an electronic soldering iron with a small tip. We don't want a giant tip, okay? Because that will be harder to put the heat exactly where you need it to be. You always want to put the iron back in its holder, whether you have a holder like this or one that just lets you set it down. You never want to set the iron directly on the surface. It should always be going back in what the iron's designed as a holder for it. The next item, you need a circuit board holder. You never want to hold the parts or the circuit board. By the way, this is the circuit board. That's this part here. You never want to hold on to parts while you are soldering. It's way, way, way too hot. So you need some kind of a circuit board holder. That'll be something that lets you clip it into place. And I use one that are called helping hands, and these allow me to clip it into place and then move these around how they need to go. There's also smaller helping hands. If you're using something that has metal clamps, metal clips to hold it on, I recommend that you put a piece of paper between the clip and the circuit board so that the board does not get scratched. That can actually hurt the traces, which are the conductive paths for the electricity. Okay, and if you have also a circuit board vise, that will work as well, but something that can hold onto the circuit board. You will need a pair of scissors. The scissors will be used to trim our little foam pad that will help hold the solar cell in place while we solder it. So you'll need scissors to trim that down. Don't trim it until we get to that step. You need wire cutters. I recommend diagonal wire cutters like this. These are also called flush cutters. And what will happen is we will use these to trim the leads off of the parts once we are to that point. Okay, you also need long nose or flat nose pliers. These will be used to gently bend the leads of our parts so that they can fit properly into the circuit board. If you do not have long nose pliers, you can get away with bending the leads with your fingers. It's just not as neat or nice looking of a bend. Okay, and last but not least here on the list of what we need, you need masking tape or electrical tape. We will only use a little bit of this, but it's definitely important. So make sure you have masking tape or electrical tape. If you don't have either of these, Scotch tape will work, like clear cellophane tape for like wrapping presents. But you want to be careful about what surface you're taping the Scotch tape, because once you peel the tape away, it'll rip the piece of paper, for instance, if you have on a piece of paper. That is it for the tools. Now, of course, I want to expand for a moment on the electronics soldering iron and solder. In addition to the soldering iron, which we'll be using to melt the solder, or more technically, we're using it to heat up the parts and the circuit board so that we can then melt the solder and join the parts together. You also do need solder, and I'm going to be using lead tin solder, which is also called 6040. If you have leadless solder, that's totally okay. You will need to apply a little more temperature in order for that solder to melt and properly bond the connections. I'll show you how that works as we go along. Now, you also need to have either a brass sponge like this that usually comes with a solder holder, or you need a wet sponge like a kitchen sponge that is slightly moist in order to wipe the soldering iron off as you go. So if your soldering iron stand has a little spot for a sponge, you need to get a little bit of water on that, but you want to wring out most of that water. And be careful that you don't set the sponge again on the family heirloom antique table, because a wet sponge or anything wet will start to ruin the wood. But so there should be some kind of metal holder with whatever solder stand you purchased. One quick note on the circuit board. The circuit boards that you all received in your kit are blue. And that's my preferred color for the kits that I release. I just like that color. But when I do prototypes, then those are green. I'm using one of my prototype circuit boards. It's almost identical to yours. The reason I'm using this is I don't want to use up one of the boards I use for my actual kits. Because if anybody else orders kits, I want to be able to have all the parts I need to send that kit out. So just a reminder, don't worry about the fact that my board is green. The color comes from what's called a solder mask. Solder mask is a layer that's placed so that it will not allow solder to bond anywhere except for the pads, which are the shiny parts. Pads are where we'll be bonding solder, and we'll be inserting parts, of course, into these different holes as we go along. Let's start by taking our circuit board holder, whichever one we're using, and I'd like you to take a look at your circuit board, and you'll notice that we have two sides, of course, and we need to make sure that the side we start with has this plus and minus and says solar cell. If we turn the circuit board over, you'll see on the opposite side it has my logo, and then it says attach C1, C2, C3. In fact, let me check. I think yours, I changed the word. No, the wording is here too. Attach C1, C2, C3, and bracket 1 to this side of the board. So when we get ready to do those parts, then we will turn the board over. But for the moment, we want the side that says solar cell. Really important that you start with this side so that the kit will work the way we intend it to. Here we have our circuit board. You notice that I'm clipping it in, and notice that my clips have little rubber feet or little rubber gloves for the tips to protect the circuit board from any scratches. Okay, Cody and Kristen asks, what's the difference between using a brass sponge versus a sponge with that's wet? Oh, okay. I see. Actually, your question is a brass sponge versus steel wool. Steel wool is way too rough. We need the sponge that's used. This is a special brass sponge. The idea is it's wiping off all the gunk from the soldering iron tip. So you either want to use a brass sponge that's made specifically for soldering irons, or a regular kitchen type sponge that's slightly wet. If you don't have a circuit or a soldering iron holder that has a sponge, then you can get an old sponge, put it on a little saucer or plate. There should not be any standing water. You want to wring most of the water out. The reason we get the kitchen type sponge wet is so that the iron won't burn the sponge when you wipe it off. And by the way, when you wipe off on a wet sponge, you want to do it very quickly. You're turning it one side and the other, moving it across to wipe off the gunk. Don't sit the iron in the wet sponge. You hear a sizzle, which is kind of fun, but that's actually severely dropping the temperature of the iron. And that does, it's called a thermal shock, which will stop the iron from being very happy. Okay, coming back here, we have our circuit board ready to go. We have the term solar cell visible, so we know we're working on the right side of the board or the correct side of the board. And I'm going to be actually looking through the instructions just to make sure I do everything in the order that I plan to do it. The first step is to install D1. Let's look on the board and we see that D1 is marked right here on the left, and it's part 1N 4148. And remember that the soldering iron, or I should say, the parts, I have pictures of each part on the actual printed list, but this is the part that we're using, okay? You have two diodes. Let me do this so that you can see it in focus. This is the first diode that we're going to use. We have one other diode, but it's big and black, and we'll be doing that one later. This is the other diode. We want this one. It's a little part. It almost looks a little orange, but the important thing to notice is it has a black line on one side. that line marks negative. It's really, really important that we put this part in the correct direction. In fact, every part that we're doing here, it's really important that you put it in the correct direction. So what we do, by the way, the paper that's on the tips, you could just, if you have paper on it, just peel that off of both sides. Okay, take your part and then notice that there's a black line on the diode and then there's a little line printed on the silk screen on the actual circuit board. And what we need you to do is make sure that that black line is lined up the same way as this line. If you put this in backwards, your circuit won't work, okay? And then what you do is hold it so you can see where the two holes need to be. Make sure you're holding it across the correct two holes. And what I like to do is actually then just hold on to it with my pliers. And then while I'm holding on to it, I gently fold down one side like this. So now you can see there's a bend. Now, if you've done my electronic classes, you're familiar with bending the leads down like a staple in order to plug them into the breadboards, the temporary circuit boards. This is similar to what you're doing here, except we're going to be soldering the part in place. Okay, and so let me see here. We had to mention that somebody thought that someone was unmuted. And nope, thank you, David, but no one is unmuted. In fact, I've confirmed that students do not have the opportunity to unmute themselves. Okay, so we're okay here. Now, once you fold down one lead, then put the lead down into its hole, and that way you know that the measurement will be correct for the other side. We'll take the pliers for the other side, and then we will bend down this, okay? Now, this diode is going to sit flush against the circuit board. Once you bend down both leads, then you should drop it right down into place like this. And I actually did okay. I got both leads measured so that it dropped right into place. If yours doesn't fit, then that's okay. Just take a moment to adjust the leads. And let me get you a little more light on here. Take a moment to adjust them, but be sure that it's sitting flush and super duper make sure that the black line on the diode is facing the white line on the circuit board like that. Okay, once you have the diode dropped and ready to go, then what I want you to do is from the other side, you want to gently pull on the diode so it's sitting flush and then pull the leads away from each other. This is called splaying the leads. This helps hold the diode in place while you turn it over to solder it. Okay, now we had the question come up, when do I turn on my soldering iron? And the answer is right now. So go ahead and plug in your iron or turn it on. And if you have a temperature setting for your iron, then set it for between 680 to 700 degrees. If you have lead-free solder, you may need to go a little bit higher in temperature. And that's Fahrenheit, by the way. If your soldering iron has a little dial, set it for just about the halfway mark or just past the halfway mark. And that should be a good way to a good temperature for you. And I'll tell you in a moment here how to check if your iron just doesn't seem to be heating up enough for it to melt the solder, then we can bump it up a little bit. Okay, so yes, 690 degrees Fahrenheit should be a very good temperature. In fact, I'll go ahead and put mine at 690. So just to show you what mine looks like, this is the base for mine. So it's heating up right now. I just dialed it to 690. Let's see here. Yep, 690, like that. Or 691. So if you don't have a variable temperature iron, that's totally okay. When you get an electronics soldering iron, even if it's a fixed temperature, then it is it's a temperature that should work well for you. Okay, sure, we had the question to go over the positive and negative on the diode. Absolutely. When you're looking at the actual diode, the little line that's printed on one side, that marks the negative side of the diode. And then also you'll see on the silk screen that the negative is also marked with, and let me make sure we're looking at the correct side of the line. Oh, okay. All right. You know what? Let's just pause here just for a moment. Brooklyn, I'm so glad you brought this up. I actually tweaked the direction of some of my parts so that the positive and negative signs would not be confusing. So I do need to use a blue circuit board. Brooklyn, thank you so much for asking about reviewing that. I wonder if you noticed the lines were wacky. Okay, so nothing changes except notice one important thing. Notice that on the blue circuit board, which you are all using, then the white line on the board is on the left. So I had my diode in backwards from what you should do. So I hope you have not started soldering yet, because we want to work together. So the line on the diode should actually be to your left, matched up with the line that is on the circuit board. Okay, so there we have it. And then I'm going to bring the leads away from each other. And we had the question, are we going to do a show and share? The best way to do a show and share is pictures posted on Facebook, or you could feel free to email me pictures to brian@superchargedscience.com. I love seeing the projects that you all have built, but we won't have time to do a show and share during class today because we have so much to cover. Okay, now that we have the diode in place, it's a little orange one, and the black line on the diode is facing towards the line that's on the circuit board, then our irons are heated up. We're going to turn the board over. By the way, you'll notice that when I'm holding onto the circuit board, I'm holding on only to the edges. That's important to do because we don't want grease from our fingers getting into the circuit board. It can mess up the electrical connections. Now that your irons are heated up, reminder, safety glass is on, and we want to have our iron in one hand and then the solder in the other. Now, if you haven't taken a soldering class with me before, here's the big trick with soldering. We are actually not feeding solder onto the iron. That might seem a little weird. What we're doing is we're using the iron to heat up the pad, which is the circle on the circuit board, and it's heating up the lead. And between those two things, once they're hot enough, then we melt the solder onto that part. Let me see how close I can get. Let me see how close I can get. Oh, David asked if my circuit blew up at all when I was prototyping. No, fortunately, this circuit did not blow up or melt any parts while I was prototyping. I did have a few times where it wasn't working, but that was because I had things like the diode plugged in the wrong direction. All right, to solder, take your iron, rest it gently against the pad and the lead so that it's heating up both of those. Once you wait for a moment, take the solder and then feed it onto the pad and onto the lead. Once you're done, then the solder should flow all the way around the pad and slightly up the lead itself, okay? Now, here's a trick. Sometimes it might take a moment for the solder to heat up. What you can do is have the solder resting right next to the leads and then lower the soldering iron right on top of the solder and then let it heat up the pad and the lead, and then voila. This part is now soldered. Okay, how'd you do? This is our first part. We want to solder both leads. We do one and then the other. And once it's in there again, then now I need to feed a little bit more solder onto my connection on the right. So I'm going to hold the iron here, reheat the solder, and then feed a little bit more in. I need to hold the iron for a moment and let go. Couple of tips. You'll notice the process. Hold the iron, feed the solder, remove the solder, remove the iron. One big mistake can happen is you accidentally remove the iron and now your whole thing of solder is stuck to the circuit board. If that happens, no problem. Just bring the iron back here and reheat it and then take the solder away, okay? Very good question. David asks, what's the smoke that seems to come up from the solder? That is a very good question. Inside this solder for electronics is something called rosin or resin or flux. It's a gel-like substance that helps clean the connection and helps the solder flow evenly. So when you hold the iron here and you melt the solder, then the extra flux is just burning away. So it actually does, Ivory, look a little bit like amber, but it is a different substance other than amber. Okay, and yes, indeed, Logan, this class is actually being recorded, and you'll be able to rewatch it from the live classes page this afternoon, but then I'll also have it posted under my electronics class on, or my electronics unit, which is unit 25. Okay, now that we've cut, or I should say, excuse me, before I cut, now that we've soldered these two leads, let's go turn this over one more time, and we want to make sure that the black line is indeed facing the line that's on the circuit board, that we soldered it in place. And then we're going to take our cutters and we need to cut these extra leads. Now, you want to leave a little bit of the wire sticking up out of the solder, and still wear safety glasses while you're trimming these, because when you trim them, then these leads that you cut off can fly away. We don't want that to happen. So you can see now I've trimmed these two leads, and they could possibly be even a little bit shorter, but you definitely want a little bit left over. Okay, if at any point when you double check a part and you find out that it is not in the correct direction, don't trim the leads. You'll need to desolder that part. In other words, remove the solder and then replace the part in the proper direction. It is so much easier to fix a part when the leads are long than when you trim them. Okay, so someone asked about other kinds of rosin. The rosin or flux that I'm talking about is specifically for soldering iron. You can't use any kind of other rosin. Okay, and thanks for the classes about my normal, or the questions about my normal class. We'll talk about that at the end of things today. We've built in our first part. How's it going? We got our first diode in. I'm gonna check off step one. Let's go ahead and do our other diode. So let's grab the other diode, which is a 1N4007 or 4004. You may have either one. Either one is totally fine. The important thing is it is the part that looks like this. This time the body of the part is black, so the line is gray. And okay, and then let me see, I had a question. How do I know it's done? I think you're asking, how do you know if the part is soldered? Well, you want to take a look when we solder this process again. The idea is you're feeding just enough solder to cover the entire pad, and then the melted solder should climb up the lead just a little bit. Okay, that's how you know that that particular connection is ready to go. David, if you're curious about the ratings for the diodes, I have that on the parts list for you. We're going to do the same thing with this diode. This time, the white stripe on the board is indeed towards the right. And so we want to make sure that the stripe on the part is lined up with the stripe on the board. And then the same thing, I'm going to hold my pliers right up against here, and then I'll bend this down like this. So now one lead is bent down. I'll put this lead through, and then I'm going to hold the other side, and then I'll bend that lead down. And of course, we want them to be bent the same direction. These are always being bent down like a staple so that they can fit in. Okay. So I had a question come in from the live classes page from Kay Mosby. Now, so the problem was between the two circuit boards, my prototype board, which is green, after I had this one, I felt that there were a few symbols that could be confusing for you all. So I flipped around some of the parts to make it as straightforward as possible. And that's why I needed to switch to one of the blue circuit boards also, so that yours looks exactly the same. So that was the problem. Okay, now you'll notice that with this diode, I did not bend them quite close enough. Okay, and so sometimes we could do a little bit of a trick. We can gently push down on the diode and see if it will flatten out. And sure enough, it did for me. So now that part is sitting flush. Before I bend the leads away from each other on the other side, I'm checking to make sure that the line on the diode matches the line on the circuit board. Super duper important. Now we'll gently pull on the leads and pull them away from each other. And then we'll turn the board over. Okay. And then we're ready to solder this. Now, we can see here we have the leads ready to go. So let's go through the process again. Okay. I'm going to show you this trick too that I showed you on the second lead. I'm going to rest the solder right against the pad and then rest the iron on top of it. That melts a tiny little bit amount of solder. The solder helps carry the heat to the pad and the lead. Now I'm going to feed some more solder, take the solder away, take the iron away, and voila, our connection is done. Let's do the next one. Same thing, I'm going to rest the solder right on the pad and melt it a little bit, and then I'm going to feed the solder all the way around. If you find that there's a really big pad and the solder isn't flowing all the way around the pad, again, the pad is the shiny part on the board, then move the solder to a different location. Try not to move the iron. You want the iron to stay as firmly in place as possible so that it has the ability to carry as much heat as possible. Okay, reminder, between soldering parts, when you put the iron back in its holder, always wipe both sides of the iron firmly in the brass sponge or on your wet sponge, and then put it back in the holder. Your iron needs to be nice and shiny on the tip like this. If it is not nice and shiny, then that means that gunk has started to collect. Technically, it's oxidation, and carbon that are joining up on the tip. That makes it more difficult for it to carry heat. So we want it to be nice and shiny. Okay, and let's come back here then and get my camera back in focus. We have these two connections ready to go. And before I trim the leads, I'm going to make sure that the line on the diode is matching the line on the circuit board. It is indeed. So then let's go ahead and trim these leads. Again, I'm leaving a little bit of the lead sticking out of the solder, and then I'm trimming off the rest like that. Okay. Now, a reminder, I'm working on going a speed that will be reasonable for the highest number of students. If you feel I'm going a little bit too fast, don't worry about it at all. Just do the best you can, and remember, this will be available as a recording to watch later. Okay, J&L asked, is it okay if the solder comes to the other side? Yes, that's okay as long as it's not a giant ball of solder. What that usually means is you may be feeding a little bit too much solder into the connection, but that is totally okay. That is expected, and that's actually part of the design for these boards, is for some of the solder to come through. And you could, it may be a little bit difficult to see, but I do have solder that came through the top of the board also. And that's, again, that is totally fine. Okay, what is next? We're on to step 3. It is time to install T1. T1 is a transistor. It's a 2N2222. And yes, indeed, we had another question come in regarding the soldering. And it should indeed be like a little mound of solder. The solder should flow all the way around the pad, which is the circle, and then slightly climb up the lead. It almost will look like a little volcano, except it has the lead sticking out of the middle. That's what we expect. If it's a ball, that means that you fed too much solder. But that's okay. That's why we build these practice boards, is so that you can gain practice in knowing how much solder to feed into your connection. Okay, so it should technically be like a little volcano. So like almost like a little mountain going up, climbing the lead. Okay, and let's go here, and we need our 2N2222 transistor. Now we need to be very, very careful because we have two parts that are almost identical to each other. Okay, and one is an IC or a little three lead chip, and the other is a transistor. Yes, the part would be 2222A. So let's look under my little microscope so you can see the two part numbers that we're working with here. Okay, and they're not even on the screen yet. Let's see here. Ah, okay, so my microscope is deactivated at the moment. Here we go. Let's do that one and then this one. Okay. And so first you can see here, this part says 2222. That's what we need right now. And yes, 2222A, that will also be perfect. The other part that we have says MCP 112. Do not use that part right now. Set that aside for the moment. We're working with the 2222. Okay, really, really important. If you put these in the wrong spot, your circuit will not work. Let me switch back over to the work view. Now, your parts may indeed come with a little piece of tape and cardboard. And so what you can do then is you could just gently peel off the tape from one corner, just however you can. And we'll just peel that tape off. And then we'll be careful not to bend the leads around a lot. And then I'm just going to run my fingers over it to make sure there's no residue from the adhesive on the end. So here it is. And I'm even going to look once more and make sure it is my 2222 part. Okay, very good. Okay, and my electronic essentials kit, David, does also come with the 2222. And we're going to talk more about what the transistor is and how it works. If you haven't taken my electronic classes, I'm going to give you a little explanation when we're ready. Let's look around our board. We need to find the spot for T1. Can you see it? It is here, T1. So we need to look really carefully. It's 2222. Notice how it has a flat line and a curve kind of represented here. That means that the flat line on the transistor itself is going to face that direction. So with the board facing us so we can read the word solar cell, also then the flat side of the transistor will be facing us. You'll notice that the leads are organized like a triangle. So we need to gently take our middle lead and bend it back just a little bit so that it can fit into all three holes. You want to then take the 2222 and then gently insert it into all three holes and make sure you get all three in. When you put this part in, this part does not sit flush. It will sit down and be a couple millimeters or so off the board. And what you want to do is go to the opposite side of the board and bend all three leads away from each other. Do your best to have the transistor sit straight up and down off of the board. And let me get my lights back over here so you can see that a little bit more. So you can see here, then the flat side is facing me, and then all three leads are through the circuit board and then slightly bent away from each other. All right, I have the 2222 transistor in the spot marked 2222. I'll turn this over, and then we're going to go right back here. And we will go ahead and solder all three of these connections. Now, a tip when you have a transistor like this, you don't want to hold the iron in the middle of these three holes. That might cause the iron to carry solder between two different pads. We don't want that to happen. Do you know what that's called when that happens, when solder goes across another connection? It's like what you would do if you wanted to drive over a river. Yes, absolutely, David. It causes a short. And the official term, yes, correct, is is bridge. That's a solder bridge. We don't want that to happen. So I'm going to hold the iron off here to the side, and then we'll go ahead and solder these parts, just like we've been doing. Do 1, 2. Remember, remove the solder before you remove the iron, and don't hesitate to rotate your circuit board so you get the best angle on your connections. Another thing to watch out for is a cold solder joint. A cold joint occurs when the pad was not hot enough. And that usually will happen, for instance, you'll notice if it kind of solder stutters, like you feed it and it goes, that means it's cooling down a little bit too much. So a cold solder joint will have a little crater in the middle that can separate the solder from the lead. That's why you want to make sure to prevent a cold solder joint, make sure that your iron is touching the pad and the lead. Okay, and now that we have all 3 of these connected, we double check, make sure that it's indeed the 2222, flat side facing us, flat side matching the line on the board. And now we can trim all 3 of these. And it's the same process, leading just a little bit above. How's everybody doing? This is our 3rd part. We're going to keep marching right along. We'll take a break when we finish the board. It'll be a break for you to get to some sunlight. But we do expect to go, well, definitely over an hour today, probably closer to 2 hours for today's class to get this all built and ready to go. Okay, we had the question about a resistor. This kit does not have a resistor in it at all. We actually don't need a resistor for this particular circuit. Okay, let's see, how are we doing here? What is next? Reminder, if your question or comment is off topic, I won't be able to respond. Let's check our parts list here. All right, next up is U1. U is the initial that's often used for an integrated circuit or an actual chip. And believe it or not, that MCP part is actually a chip in there, the MCP112. So it looks just like a transistor. That's why we have to be so careful. This is the MCP112. See, can we read the printing on there here? MCP112. Don't worry about all those extra gobbledygooks on there. All we're concerned is it says MCP112. That's what we're after, okay? So, Brooklyn, I'm not sure I understand your question. Is the 3rd connector, the 3rd part, I think you're saying? The 3rd component is the 2222. And yes, it could say JCPN 2222. That 2222 is the important factor. If it is a part that looks like this, and it has 22 printed on it, that is the transistor, and that goes in the spot for T1. We're now going to move on to, and thanks for asking for that clarification. It's always good to double check. Here we have our spot for MCP112 marked as U1. And it goes in the same way. We have the flat side will face us. Now, you'll notice that the leads look a little different because the leads on this one are probably straight on yours, and that's totally okay. The process is the same. Very carefully, I'm going to take my pliers just to push down on that lead so that the middle lead is away from the flat side, and that should be enough that I can now get all 3 leads into their 3 proper holes. And it's okay if it takes a moment to do this. You can see it's even taking me a moment. When you press this transistor in, we would like it to be as close in height as the, I should apologize, this is not a transistor, it's a chip. But it's the same kind of package or part in appearance. Okay, we want it to be as close in height as the other part that it looks like as T1. So do your best to get the same height. But what I'm most concerned is that the flat side is facing you and that it is indeed the MCP112. Once you have that in place, go ahead and turn the circuit board over and we'll solder those 3 parts. Okay, So questions coming in. Ivory asked a question, if there's any kind of part that has a Z. I'm not aware of any electronic part that has a Z in the initial, but there could be. And we'll talk about the transistor a little bit more when we explain the circuit, okay? And let's go ahead and solder the 3 parts for the MCP112. This is the mechanics part of beam. This is the part that actually allows our whole circuit to work, okay? I'm gonna solder all 3 here. There's 1, and then I'm doing my best not to put the iron in the middle, so we'll do this. And then 1 more. You see I'm rotating the circuit board around, or the whole holder around really, so that I have a different angle on the circuit board. There we have it. There's our MCP112 in place. I'm gonna turn this over, make sure indeed that I had the flat side facing me and that it's MCP112, and we're ready to trim these leads. Okay, and then we're ready to go. Because I want to give everyone an extra moment in time to get this part in place. Let's see here. We had the question, does it matter the order you put the parts in the board? Well, when you're building a kit, yes, I highly recommend that you always build them in the order that the instructions tell you, which is the way I'm doing it. That way, because sometimes parts are more difficult to install if you do them in a different order. They get very close to each other. Also, it can be difficult to have a place to hold onto the circuit board as it becomes more populated or full of parts. So there's always a good order. Officially, the order that I like to work is I start with the parts that are lowest or to the circuit board, or the parts that are smallest, and then I go to taller and taller parts. That's my general rule. And that's going to be true for this, except for the soldering, the solar cell, which is the most complicated part to install. So I do save that for last. Okay, we've finished step 4. We have 1 more part to install before we turn the board over. That's going to be capacitor C4. And we can see here, printed right here on the board, it's a 1 microfarad capacitor. Now, when we're looking at our capacitors, we have 3 that are the same, and then 1 that is different. And so just to show you what they all look like here, we have 3 that are the same. We'll be installing those soon. Those are the feet, and we're going to install those from the other side. And then we have this small one. This is the one we're after right now, the 1 microfarad. And same thing, we have some paper. Now, this is not always the case or situation, but in this situation, you don't actually need to peel the tape. But we do need to take a moment because we can actually trim the leads. Okay, but notice that one of these leads is shorter. That is the negative lead. And we can also tell the negative side by the white line across the actual package with that little minus sign. If you're not familiar with this part, this is called an electrolytic capacitor. This is a part that temporarily stores electrons. This kind of capacitor is polarized, which means it cares very much about positive and negative. So we need to be sure we install this the correct direction. What we can do actually is, instead of trying to wrangle this out of the tape, we can actually trim it with the leads as long as possible. Remember, keep the leads really long. We could trim this here. And so now I have these leads, but I still know my negative side because of that white line here. Okay, and that's going to go right here into C4 with the negative facing the white line here goes into the negative marked spot. So let's get both of these. This part will not sit flush, but you do want to press it slightly in so that it sits almost flush, and it should be standing straight up and down as good as you can. Once I've press this one into place, then I'm gently bending the leads away from each other to hold it in place. I'm going to make sure that the white line here is matching the negative sign on the board. And now we'll turn the capacitor over, or I should say the circuit board over, and then we'll solder the two leads for the capacitor. Okay. Nope, David, no ceramic capacitors in this kit. All the capacitors in this kit are electrolytic. Now you'll notice this pad is bigger. I wanted to give you some pads that were larger just to show you a difference in how it could be to solder with different size pads. But you do want the solder to flow across the entire pad and, as always, slightly up the lead, okay? So the way to tell the capacitor polarity is the white line with the minus sign, that's negative. So then the other side is positive that does not have the white marking line. So be really sure that the negative side is placed into the side that's marked negative on the circuit board. All right, as always, now that I've double checked the polarity for my part that's plugged in the right way, then I'm going to trim the extra part off of this lead. Okay. And then here we go. This is 4 parts ready to go. Now, on my instructions, I point out for the next few steps, we need to turn the board over, okay? And what you're gonna do then is take the board and turn it over so that you're looking at the side where we've been soldering so far. You should be able to see the FutureVision Research logo. So turn the board over like that, okay? And then we're ready to go. We're going to install the bracket, which is going to hold our little motor. And the motor is what's going to make our beambot bounce around. So grab the bracket. It looks like this. It's like a little U with 2 little tabs. Do not put the motor in the bracket yet. We want the motor out of the way. Okay? And what you're going to do is take the bracket and then just drop it right into those 2 holes right there on the board. It's the 2 biggest pads on the entire thing. Okay? And we're going to apply a little bit of solder from this side to help hold it in place. That way, when we turn the board over to finish soldering it, then the solder will hold it where it needs to be. So go ahead and take your iron and you're going to rest the iron, again, right onto the pad and the little spot where the lead is dropping into. Let me get this a little more centered for you. Same trick, I'm going to rest the iron right onto a little bit of solder to help carry the heat. It's going to take a moment for the iron to heat up the bracket hot enough. By the way, do not touch this bracket for a while. Okay, now that it's hot enough, then I'm going to feed in the solder. And I actually fed so fast that the solder cooled down. And remember, you're feeding just a little bit, just enough so that there's a little bit of a solder connection between the pin that's going down into the pad and the pad itself. And then we'll do the same thing, a little bit of solder on the other side. And I'll say again, do not touch this bracket now. It'll burn you instantly, so be very careful. Now that we have a little bit of solder on both sides, I'm going to be careful when I hold the board that I don't touch that bracket. So you can see now the bracket is sitting like this. Okay? And if it is not sitting quite flush, that's okay. We do want it to be as far down as possible though. And so I'm satisfied with how this bracket is sitting. We're now going to turn the board over to the side that has our other parts. And that way we can finish soldering this bracket. So we can see here that the little tabs for the motor bracket are sticking through here. And we're just going to now, we need to be careful now we have other parts around. We need to arrange the board a way to where I can get the iron in here and then heat up the tab and the pad, and then I'm going to feed solder all the way in here. It's a good amount of solder for this. Once we're done, again, solder should be flowing across the entire pad and slightly up the tab in the middle. Okay? And then I'll do the same thing here. And if you are trying to get solder to flow across the whole pad, move the solder, but keep the iron in place. Have I said it enough? I'll say it again. Do not touch the bracket. It's so hot. You do not want it to touch. You don't want to touch that bracket for a while. I can even feel heat radiating off of it a little bit. Be very careful not to touch that. There we have it. There's our bracket ready to go. Okay. Now that we have the bracket, we're going to turn back over so that we're on the side that has the FutureVision Research logo, where we can see the actual bracket. It's time to install the 3 capacitors. We're almost done with our parts. Did you know that? Once we do these 3 capacitors, all we'll have is the motor and the solar cell, and we're done. Now, these are electrolytic capacitors. All 3 of these are the same. Each is a capacitance of 1,000 microfarads. And you can install them in any order you like. We're, of course, going to start with C1, because why not start with 1? We have to be very careful, though, to install every one exactly the same way. But before we install these, this is something unique. Capacitors would not normally be used as feet, but we're using the 3 capacitors as feet in this particular case. So you can see this is what the capacitors will look like when we're done. We need them to barely go through the board, and then we're going to solder them. So here's what I need you to do. I need you to take all 3 capacitors and then take your long nose pliers, and you're going to take your pliers so that you're holding it just across the leads close to where the short lead is. I want the short lead and the long lead to stick out the other side, but I want to keep track of this, and then I'm going to bend the capacitor at a 90-degree angle like that. Okay? And we need to do the same for all 3 capacitors. And I'd like them to all be bent exactly the same way. In other words, so that you can see here, I have, while looking at the negative side, I'm bending it towards the right. It's okay if you do left or right, that doesn't matter, but I recommend you do all 3 the same way, and it will matter positive and negative when we actually hook them into the board, okay? And we had a question, why is the bracket on the other side of the board? That will be to hold the motor. The motor is on the bottom of this project, on the robot. So yes, all 3 of these capacitors are identical at 1,000 microfarads with a 10-volt rating. Now that we've bent all 3 leads so that they are ready to go, that way we can insert them in and they'll be able to hang. Okay, so here I have my board. I'll start with C1, and I'm making a note of the negative side here, very important. That's the short lead. And then from the, whoops, I need to be careful. I actually almost did this backwards. We're inserting it from the side that has the bracket. Okay, so I need to take this, again, the negative side, and I'm going to, now when I bent it in a way that's a little more cumbersome to install, but that's okay, it will still go in. We want the capacitor to go into the holes. Let me move my hand so you can see it. So you can see now it's in the holes, but if I try to tug on it, it's catching on the leads that we bent over. That will hold it in place. Let's go ahead and actually place all 3 capacitors so that when we turn the board over, we'll be able to solder all 3 parts. For every single part that you do, make sure you line up the negative and short lead with the negative on the circuit board, and then we'll insert those in. It's okay if they drop flush onto the board because we're going to not solder them, so we'll let them drop and be the full length. And I'll do my last part here. So now, and you can see it's the edges. These capacitors go on the edges. All 3 are inserted. I'm double checking to make sure my negative sign matches the negative symbol on the capacitor. Really important. Yep, yep, yep. I'm good all the way across. Okay. So it doesn't matter really what order between capacitor 1, 2, and 3 that you install, as long as you make sure that the polarity is correct. Okay. So if you accidentally solder a part incorrectly, so for instance, I had a student who accidentally soldered the bracket to the wrong side, then your circuit, yeah, so technically you'll need to desolder it in order to move it to the other side. Technically, Liam, your circuit could still work. The motor will it? Let me see. I'm actually going to check. Yeah, technically it would still work. Your motor will just be covering a little bit of the solar cell, but I'd say keep on going. You'll just clip the motor to the other side. I think you'll be okay, Liam. But officially, we want the motor bracket to be on the opposite side from the solar cell. Okay, so don't worry about it. Now you can see I have all 3 capacitors hanging from the bottom of the board, and they're stretched out, right? Because we need them to be the legs. So the fact that we bent the leads is what's preventing them from dropping out. We want the capacitors to be going straight down the bottom of the board, and then we'll bend them the way we need them to go. So do your best to have the circuit board, when you clip it back in place, I recommend having it straight up and down. And here's another way to check. Remember, the shorter lead is negative, so we have the short lead and the negative sign here, and I'm going to check the other capacitor, short lead, negative side, and then over here, my third capacitor, short lead, negative side. Awesome, we are good. Okay, let's solder all 3 of these capacitors into place. Here we go, solder, solder, solder. Now, it's not usual that we would have leads that are flat against the circuit board, but this is the best way really that I've seen to do it, and it'll be okay. We could still trim the extra leads. Okay, and looking good. Again, try to make sure that the capacitors are sitting straight down so that they'll be as even as possible when they'll act as feet. And then I'm going to get my last capacitor soldered in here. One and one. That's it. All 3 of my capacitors are in place. Wow, Jane L, you finished your circuit. Good job. And that's okay, folks. If you haven't finished, the Jane L, they've I believe have soldered before. So excellent job. We are all ready with all 3 of our capacitors soldered in here now. We'll need to be a little more careful when we trim these leads because I don't want to scratch my circuit board. So I'm going to gently come in. I was holding my flat leg or my long nose pliers. That's not going to work. I can't trim anything here. I need to grab my flush cutters. Okay, and then let's do our best to trim these leads. Again, ideally we want a little bit sticking out the end of the solder. Ivory asked how fast can we melt solder? Frankly, that all depends on the temperature of your iron. The hotter the iron temperature, the faster it will bring everything up in order to melt the solder. But we do not want this iron too hot. The iron should only be hot enough to heat up the part and then allow the solder to melt. If a soldering iron is too hot, then it will actually bake the pad right off of the circuit board and ruin it. So that's why you never use a solder gun with electronic soldering. A solder gun gives you too much heat. Okay, so 690 Fahrenheit should be fine. And the question is, how fast can you do it? Well, you're seeing that speed of melting solder right now with what we're building today. Here's how your 3 capacitors should look. They should be on the same side of the board as the bracket. And then on the top side of the board, we should have our two transistor and MCP112, one capacitor, and then the two diodes. Okay? So what is up next? Up next is the motor. Okay? So let's see, I think it's time for another quick drink of water. You all are doing an excellent job. We've been working over an hour now. I want to keep going on the circuit so that we can get this built. And okay, and so here we have it ready to go with our next part. Next up is going to be the motor. So what I'd like you to do is take your motor and then clip it into place. If you had accidentally put the motor on the opposite side, then that's okay. Just clip it here, and the bracket will still hold it out of the way from the solar cell. But Liam, what you'll need to do is you'll need to pop the motor back off when we install the solar cell, but that's okay. But what we're gonna do is we're gonna take the motor and then just press it right in so that it clips into this, like that. So that's what the motor should look like. Okay, this is a DC motor. In other words, a direct current motor. That means it has polarity. If we put positive onto red and negative onto black, it'll spin one direction. And if we reverse that, it'll spin the opposite direction. The direction of the motor does not matter in our situation. So you can put whichever color you want in which. But the connections for the motor are important. Again, you're going to clip the motor into place, and then what will happen is the wires are going to just wrap the outside of the board to the top. So you'll notice here we have two little pads, MTR1, MTR2. That stands for motor 1 and motor 2. Take one of the two colors, and let's just do one at a time. Reach the wire around, and then, let me see, just reach it around here and then insert it through the top of the board. Okay, and it may flip right out. So one thing that you can do, if your wire just plops out, you can take a little tiny piece of masking tape and then use the masking tape to hold it in place. So that's what I'm gonna do. I have a wire going in here to motor 1, and while I'm holding it in place, I'm just gonna put a little bit of piece of tape like that so that it's now holding it in place. Now when I turn it over, do you see the wire sticking through? We should see the wire sticking through the little pad right there. That's how it should be. The board's starting to get a little crowded, isn't it? But that's because we're almost done with our installation, so we have lots of parts. Okay, so here we have it. Just to give you a frame of reference, this is the wire sticking through the pad, and I need that to be right here. I'm going to try to get a good angle for you. And we need to solder that wire into place. Okay, there's that. And then we need to do the, we'll trim the wires in a moment. Then I'm going to do the exact same thing. I can take the masking tape off now, and I'm just going to kind of organize that wire. And then I'll take the other wire from the motor, insert it into the other pad, and yeah, it just flops right out. So I'm going to hold it in place, and then I use my little bit of masking tape. Like that, okay. And sure enough, there's the wire through the hole, ready to go. And let me get a good angle for you. You can see here it is right here. And solder that one. We had the question, do I use AC motors? I really don't do anything with AC motors. Everything I'm working with most of the time is direct current. So I use direct current motors. And in fact, with robotics, most of the time also, we're working with DC motors. We like them because it's easy to change direction that it's spinning. Okay, here we have it. You could see then the two motor wires are wrapping around the other side of the board, and now they're into place. And again, there is no positive or negative because it doesn't matter which way the motor's spinning. The motor's ready to go. Okay. Now, while we're here, let's take a moment and we're going to just gently bend the 3 capacitors away, slightly away from each other, like that. They should be at a slight angle. That just helps give it a little bit of stability. And you can adjust how sharp of a bend these have to see if you could change how much it bounces around once we're done. All we have is a solar cell, and we have finished building our beam robot. How are you feeling? I'd say this is a good moment to take a moment and just stand up, stretch. Been working a long time. Oh, that feels good to stretch my legs. Okay. All right, back to it. The solar cell is the most complicated piece to install. So I really need you to stick with me, especially if this is your first time soldering. We're going to go through it step by step. If you install the soldering or the solar cell backwards, it is very difficult to take it off of the board and put it back in. And the reason is the polarity. So when you look at the solar cell, it has a plus sign and a negative sign. So this little bar here, that is the connection for their solar cell for positive, that's closest to that plus. And this little bar is the connection for the negative. We need to be very, very careful that when we install this, we're placing the positive side onto the positive marked. We'll be flipping it over and then inserting it into the 4 holes. Okay, and it's a different size solar cell. This one is able to produce 6 volts, which is useful for this particular circuit. All right, let's go ahead and go through the steps. Make sure you have your tape handy. This is where we're definitely going to need the tape. Okay, all right, let's see here. So the first thing, you probably saw this little squiggle of wire that was in your kit. It's time for that squiggle of wire. Go ahead and take the wire out of its baggie, and then we will stretch it out. And we need to cut this in half. Be very careful. If you cut these too short, then we're not going to be able to use them. So take your bit of wire and then stretch it out. What you could do is you hold on to one side. So I'm holding now to the ends, and then I'll just make it nice and long. It's okay if they're not perfectly even, but we want them as close to the same length as possible. Now that I have this folded over, I'm going to cut right here at the bend. Okay, so now we have our 2 segments of wire. And this wire still has a little bend on the end. I'm going to use my pliers to straighten that out because these wires are going to insert down into the circuit board, so I want them to be nice and straight. Now that you have your wires ready to go, you can peel the little plastic off of the solar cell and then go ahead and lay the solar cell down on a surface. This will be the one time where we're soldering on a surface, not using the holder. We're going to lay this down flat, and then what we need to do is lay a wire across this metal conductive pad like this, okay? And it's going to take a minute for you to do. Take your time with this. We want there to be an equal amount of wire as close as possible to both sides, because we're going to fold those 2 leads down, and then they're going to go down into one side like a staple. And then for the negative connection, we'll fold those 2 wings down, and then they'll go onto the other side. With one wire here, now it's time for masking tape. Okay, and what I'm going to do is I'm going to use my finger, and then I recommend putting the tape right onto the edge of the solar cell, and then onto whatever surface you're soldering on. Is we want to hold the wire flat against the metal part so we can solder it. Okay, now let me see how close I can zoom in and keep this in focus. And of course I can't move my solar cell now because I just taped it into place. it's okay if the wire doesn't go across the middle. You can see mine's kind of a little lower on the left and then a little higher on the right. That's okay. Once I have this taped down like this, we're going to solder that connection. What we're after here is we're soldering all the way across this metal pad. It is okay if solder doesn't cover the entire pad, but we want at least half of it to have solder on it. So, and again, take your time with this. Make sure it's taped down firmly. And I'm still going to do the trick. I'm going to hold the solder against the pad and the wire, and then drop the iron on top of it so I have a little bit of solder helping to carry heat. And now that it's hot enough, I'm going to flow. Now, in this case here, I'm going to actually follow my rule of not moving the iron, and I'm going to feed solder from the opposite side, and now I'll take it away. This is what your connection should look like. Solder traveling in a little bar all the way across one side. And then your wire then is held in place. Okay? And you can even leave this tape while you do the other side, but I need to move mine so that you could see me do the other side. We're going to do the same thing with the other side. Okay? And we'll lay the wire here. What I do is when I lay the wire across, it still is kind of springing up away from the little rectangle, but that's okay because when I put my tape down, then the tape is holding it in place better, or holding the wire in place, I should say. Okay, and one more piece of tape. And I'm gonna get it as close here in the middle. By the way, the reason this is necessary, most small solar cells are surface mount parts. In other words, they're parts that are expected to go straight on the surface of a board, and then they actually use a solder paste, and then they put it into special ovens that melts the solder in order to join that electronic part to the board. Surface mount parts allow them to be much smaller, and you could fit more parts onto a circuit. The problem is when we want to put it onto a regular circuit board, we have to go through something like this. But I feel this process works out pretty well. I have my other wire laid here across the pad. And so I'm going to do my same trick. I'll rest the iron right on top of a little bit of solder, hold it in place to let the wire and the pad heat up, and then I'll feed it. If the solder balls up on the iron, that means that the pad itself is not hot enough yet. Okay, I'm going to hold the iron here for just a moment, and voila, that side is done now as well. Hold on for just a moment before you touch this because those wires are really hot. Okay. In fact, after you solder both of these, while you're waiting for that to cool, let's work on our little pad. This pad is going to go right between the solar cell, between the positive and negative. When we put this sticker in place, we do not want to cover our positive and negative symbols on the solar cell. Really, really important that we keep those in place. So what we're going to do is take our scissors here, and I'm just going to cut this down just a little bit. The idea is I don't want to be able to see this pad from when I turn the solar cell over. So I've cut it so that it's small enough to fit right here over the writing on the solar cell, but it's not covering up the plus and the minus. Okay, I'm going to go ahead and pull my tape away now. And here we have it. Okay, remember, work with me on this because we've got to pay attention to the plus and the minus on the circuit board. Let's peel off, this is two-sided foam tape, by the way, is what this is. So whichever side you want, carefully just peel away the little cover so that you have the sticky side, and then put the sticky right, first rest it on here. Don't push down until you are positive you can still see the minus and the plus. I can, so just a quick little press. Nothing hard, you don't have to get a hammer. Definitely don't get a hammer. The poor little solar cell will crack into many billion pieces and that would be bad. Here we have our solar cell ready to install. I'm gonna back out my zoom here a little bit. Okay, so it has its two little wings off here to the sides. We have the two-sided tape ready to go, and we have our plus and our minus. All right, let's put it in place. Yes, indeed, Ivory, it would crumble like a cookie if we hit it with a hammer, so we definitely don't want to do that. Here's what you're going to do. Take the 4 wires and then gently just bend them down. Okay, so here we are, ready to install the solar cell onto the circuit board. Super duper. I even recommend, if there's anybody else with you, talk about this amongst yourselves. Say, hello, companion. Notice that the plus sign on the circuit board is lined up with the plus side on the solar cell. And I'm going to flip this over and put them into place. What I am not going to do is accidentally rotate this around, because then Brian will explode. No, Brian won't explode, but what will happen is your circuit will not work. Don't do this. The plus needs to line up with the plus, and then you're going to turn this up. And then I even recommend, look over here. Ah, yes, there's the plus sign, and it's going to go onto the side. And then what you want to do is install all 4 wires into the 4 holes. And I'll show you what this looks like after I get this last wire in. Take your time. It could be a little bit hard to coordinate all 4 wires to go where they want to go. Okay, and now with all 4 wires in, guess what you're going to do one more time? All 4 wires are in. You're going to say, hey, there's the plus. Is it on the same side as the plus on the circuit board? Yes, it is. Well, darn it. You know what I forgot? I went through all that, and that was the practice run. I forgot to peel the other side off of the foam tape. So peel the other side off the foam tape. Now, the foam tape is not a permanent part of this. The foam tape is holding the solar cell in place while we solder it. Now that I've peeled the other backing off of the other side of this foam tape, all right, we're going to be careful again. All 4 wires need to go in. And let's just do that. That's funny, David, you brought up my neighbor joke from my quiz. Okay, all 4 in. There we go. And before I press it again, okay, is it plus here? And it's a little dark for me. There's a plus, and then that's lined up with the plus on the circuit board. Excellent. And so then I'm just going to gently press the solar cell, and it is not going to set flush because of that foam. So don't try to push on the ends. You don't want to crack this. Okay, you're just going to press it in, and here's what we do. We're going to take the 2 wires and then twist them like a little twisty tie to each other. So the 2 wires for the positive side, cross them over and give them a couple of twists like that. And then do the same thing for the other side. Couple of wires, twist like that, and that helps hold the wires down. The foam is helping it in place, and these 4 connections are now ready to solder. Okay. And so, Josiah, I just saw your question. Yes, indeed, this part that we're working on now is a solar cell, and it's going to provide the electricity for our circuit to work. Okay. Liam, you probably figured this out, but you'll need to have the motor out of the way when you install the solar cell, and then you can clip it back in. Let's go ahead now and solder all 4 of these connections. And it's the same process, just basically you're going to find an angle that works for you to get the iron in here. And as always, you want the solder to cover the whole pad. You'll notice that the holes are offset in these pads. In other words, the hole is on one side, and that's totally okay. You just want to solder the rest. Now I have a cold solder joint here a little bit. There's a little dimple in my solder showing that it did not actually join with the wire. And that's because I'm having to heat up a bigger piece of wire. So I need to bring my iron back in here and then hold it for a moment, get it up to temperature, and now that's looking a lot better. I need to be careful here. I'm getting really close to the little gripper, and I don't want to melt my gripper, so I'm going to move that side, and then we'll solder this one. And one more. We're almost done, folks. Remember, after we finish the circuit, we'll have a tiny little break to test our circuits in sunlight, and then we'll learn how this circuit works. Okay, and let's see, I'm gonna come in here like this. Good. Okay, so Brooklyn was asking what wires we twist together. Very good question. When you're inserting the 4 wires that we built from the, in fact, I'll show you here. This is from my printed instructions. We laid out the wires across the solar cell, we taped them, and then we soldered those onto the pads here and here. After you solder them, then you're going to insert those 4 wires flat into these 4 holes, making sure that the positive and the positives line up. Once all the 2 wires go through for positive and the 2 wires go for negative, when you turn the board over, then you're going to twist those wires together. That is just to help hold them tight. It's helping keep the solar cell firm. And then now that we've soldered all 4 connections, we can trim these wires off. So that's what the wires were, okay? So let's go ahead and same thing as always, we're gonna let a little bit of the wire stick out of the top of the solder. Like this. And so now all 4 of those are soldered and ready to go. I'm noticing I forgot to trim my 2 motor wires. Notice how they're here next to the bracket. So I'm going to take a moment to just trim those while I'm here. Okay. Now, before we go out into some sunlight, we need to take a moment. It is very important to inspect your board. Look around your board and make sure that there are no little bits of wire trimmings laying across any contacts. Those wire trimmings, will be a short circuit which could damage your circuit. Also check and make sure that you don't have solder going between any 2 connections on the board itself. Remember, that is a bridge that causes a short circuit, which is very bad. Here we have our circuit ready to go, and we have installed all the parts. And right now, even in fluorescent light, your solar cell is making some electricity, but not enough to start this going. So it's now time, well, as soon as you finish your circuit, then a couple things to keep in mind. One, after you test this, before you come back, wash your hands with soap and water to get the lead off. And instead of getting the lead out, right? Do your parents ever say that if you're moving too slow in the morning? Get the lead out. Well, in this case, we're getting the lead off our fingers, our fingertips, okay? And then come on back and we're gonna learn how this circuit works. Let's go through an explanation. Let's talk about this circuit. Here is the schematic for the Miller solar engine. That is the circuit that you're using in your BeamBot. Miller is actually the nickname of a man named Mark Tilden. Mark actually is a robotic engineer, and he's the one who's credited with designing the circuit that we're using today. His nickname is Miller, and so that's where we get the term Miller solar engine. Okay, let's go through and talk about the parts. You can see here really quickly. Oh, I'm going to turn on my pointer. Ready? Okay. And we'll talk about these parts one by one as I explain the circuit. SC1 is a solar cell, and capacitor C1, C2, C3, these are the 3 feet. And then U1 is the MCP112, which is that transistor looking part on the top part of the board. And then we have capacitor C4, that's the smaller capacitor that you see on your board. Diode D1, that's the little orange diode. And then of course, bracket here, BRKT1, that's the motor bracket. I have it on the schematic because it actually has a connection to ground. And then here's the transistor, 2N2222. We'll talk about that. We had the question, is it PNP or NPN? And we'll talk about that when we cover the transistor in just a moment. Here's a diode, the other one, that's the black one. And then this is the motor. So that's all of the parts. Let's talk about how they behave. All right, when we're looking at the solar cell, when you see the symbol, you notice that's a symbol for a battery. And the long lead is positive. The short lead here on the little diagram is negative. So positive runs here through the positive connections of the 3 capacitors. It goes into the positive for capacitor C4, and then into the connection called VDD that's right here. We'll talk about what that means in a moment. So the solar cell is generating power. It is generating voltage and current, and it is designed to give up to 6 volts. But the amount of voltage it provides depends on how much light it's actually seeing, and it needs to be actual sunlight or light from an incandescent bulb. In other words, something that has a filament in it. Okay, so the solar cell generates the electricity. Next up, we have the 3 capacitors. They are each 1,000 microfarads. Are they connected in parallel or serial with each other? What do you say? What do you think? I'm thinking some of you are mouthing the answer. Serial as in S-E-R-I-A-L. Serial like that. Serial means in line with each other. Like a television series. Series, you go from one show to the next to the next. And then parallel is the others. And these are indeed in parallel. Parallel is actually then how we add the capacitors together. These are each 1,000 microfarads. So this is a total of 3,000 microfarads. Okay, and by the way, what is a microfarad? We had Liver and Onions just ask that question. A farad is the measurement for capacitance. In other words, how many electrons is it holding? Electrons are what carry electrical energy, and that's what makes this work. Our solar cell is generating electrons, and then these 3 capacitors are storing them up. So think of it like solar cell is filling up a bucket with water. It's filling these 3 capacitors with electrons. Okay? As we are filling up these 3 capacitors with electrons then, the MCP 112, that is called a voltage supervisor or IC supervisor. And it is watching the voltage across VDD and VSS. Now, what in the world are those terms? VDD stands for voltage at drain, and VSS, voltage at source. Source and drain, we actually just learned about this in my last electronics class. Those are 2 of the connections for CMOS or MOSFET transistors. That just describes the kind of connection they have. Okay, VDD that's drain. Remember, and then here is source. Electrons are on the negative side of a battery, so that is the source for electrons. So VSS is the negative connection, VDD is the positive connection. And this little part is watching, it's like a little voltmeter. It's measuring the voltage that it sees coming from the 3 capacitors. The 3 capacitors are indeed connected. They're connected here in the common positive pathway, which is all built right into the circuit board. Okay? And so as the voltage supervisor is watching the voltage is increasing in these capacitors. Once it gets to 3.08 volts, then it actually turns on voltage on the V out pin. So it is like a little valve. It's watching with binoculars maybe. Little tiny microscopic microchip binoculars saying, are you at 3.8 volts yet? Are you? It keeps on looking. And as soon as the voltage from the 3 capacitors that are filling up, as soon as they reach 3.08 volts, then bam, it flips the switch and it sends a positive voltage to V out. Yes, I agree, Ivory. It's like it is interrogating it or asking the question. Okay? And so then, so we have the question asking, what does the circuit do? And that's what we're looking at right now is we're looking at how this circuit, this is the circuit, by the way, that your BeamBot is using. So this is the diagram of what the circuit board's designed to do, okay? And it's all the exact same parts. So the voltage across these 3 capacitors has reached 3.08. And by the way, that's what this part is designed. You could get voltage supervisors that are designed for certain threshold voltages. Threshold is the voltage it's watching for. Now that it's sent a positive voltage to the base or middle connection, it turns on this transistor. In other words, it makes it active. And now a word from our sponsor, bipolar junction transistors. I'm going to talk to you about these transistors. This is a slide from my regular class. I want to make sure that this part makes sense to everybody. Transistors are a switch you control with electricity. This is the diagram of the kind of transistor you have in your kit. Or I should say, yes, in your soldering kit. It is an NPN transistor. That describes negative, positive, negative. In other words, when we give the base, the middle pin, when we give it a positive voltage, then it allows current to flow through the other 2 pins, which are called the collector and the emitter. We know it's NPN because the arrow in the drawing is not pointing in. This gives you another representation. The base is like a valve, which will allow water to flow when you give it a voltage, but then you can also control how much it is allowing to flow through. So this is a quick little intro to bipolar junction transistors. Bipolar, by the way, means 2. So it has either 2 negatives or 2 positives. And that's what our part is in our circuit today. The 2222 transistor, when it sees a positive voltage of at least 0.7 volts, then it allows current to flow through the other 2 leads. What's happening is the transistor is allowing the motor and then, of course, then this diode, but it's allowing the motor to have a negative connection to ground. That causes the motor to spin. So when the transistor goes active, which means it's allowing current to flow, the transistor allows the motor to have a negative connection. That causes the motor to spin. On the positive side of the motor, it's always had a connection to positive. So it's happy there just sitting with the positive connection. But remember, in order for electrons to flow, they must be able to get from the negative side of the battery all the way around to the positive side. That's what the transistor is doing. When the transistor goes active, it allows a connection to the negative, causing the motor to spin. All right, and that's what's happening there. Now, there's a couple other parts you've noticed. What about D2? D2, this diode, is protecting from coil kickback. Coil kickback occurs because the motor is being driven by an electromagnet. It's generating a magnetic field, causing the armature, the middle part, to spin, and then that magnetic field collapses. When that field collapses, it actually sends a large amount of voltage out the motor. That would destroy this transistor. And yes, it is kind of working like a generator. That is similar to how generators work. But we don't want that. Sending voltage out will actually damage the transistor and possibly our integrated circuit. So that's what this diode is doing. It is protecting from coil kickback. Now, that's diode 2. We have a couple other parts to talk about. Diode D1, remember, diodes only allow current to flow one direction. It's preventing a positive voltage from entering into the negative connection of our chip. So this is the little protection diode. Last but not least, we have our C4. C4 controls how long the voltage supervisor turns on. So remember, the chip here, the voltage supervisor watches the voltage. When it gets to 3.08 volts, then it activates the transistor. How long does it keep the transistor active? That is determined by this capacitance, 1 microfarad. Okay, so in other words, by having a large capacitance, let's say of 3,000 microfarads, and a small capacitance on C4, that allows a high burst of energy to go out the motor. And then, so what happens is it goes through this cycle over and over again. The solar cell charges the capacitors. When they reach the proper voltage, it gets dumped into the motor, causing it to spin in a little burst. That drains these 3 capacitors, and then it starts all over again. The solar cell starts charging it up. And then as soon as the voltage is high enough, another burst. It is the combination then of this capacitor here, which we're using 3 because I needed 3 feet. That could be one large capacitor that, let's say 3,000 microfarads, but I needed 3 feet, so I used 3 in parallel. By the way, one last term to let you know, this motor is an example of an ERM motor. That stands for eccentric rotating mass. In other words, this little weight is off center, meaning eccentric, and it's rotating around. This is the kind of motor that cell phones have for vibrate mode, where they go bzz, bzz. That's what's in here, although they're often smaller in modern cell phones. And that will do it for today. Have a great rest of your day. Have fun experimenting with your BeamBot, and we'll see you soon. Bye.